your part's the review part. Right, so if I give you the equation, x cubed minus 4x squared minus 2x plus 20, very similar to your quiz, right? How many answers are there? How many roots? Three. How do we know that?
Because of the cube.
Because of the cube. What does it look like? If I did a sketch without doing anything, where would it start, where would it end, and why? Why? Yes? Because it's odd and positive tells you how it ends, right? So I know this graph looks like so.
Wait, how is it?
Odd is the cube.
Oh, yeah.
All right?
Yeah.
Positive tells you how it ends. So I know what this thing looks like or have a general idea of what it looks like before you start. If you don't do that, sometimes your graph's kind of weird. Hey guys, on your quiz, we had 1/3, 3, and 3. What did the double 3 tell you? It was 2 roots. So when you graph that thing, it should have went through 1/3, and what did it do at 3?
It went through twice.
It went through twice, which means it doesn't cross it. It goes up, so it hits it once, and then it turns. That's what the double 3 means. All right?
Dude, you just
so you're aware.
Why couldn't you just put 3? It's only hitting once.
No, it's hitting twice.
Hitting
Hitting
twice.
twice.
Because you're gonna hit the left. No, you're gonna hit the left.
I just see one.
All right.
There were hits.
If you have a wave, it has 2 sides.
I would agree with Costa.
So every wave has 2 sides.
Right.
So this part of this wave goes up and hits there. Where does this side of this wave hit? Right there. Where does this side of this wave hit?
Exactly 3.
So
Exactly 3.
That's 1 dot.
That is
One
two.
dot, but it represents 2
Oh.
roots.
You can say that for every one then.
No, you can't.
I got you.
1/3 only hits once.
Yep, I see.
Yeah,
What about when it comes up from the bottom of the 1/3?
It doesn't, because it's a cube that goes down forever. All right, that's just going back over your thing. Now, on your test, I asked you to tell me, list all the possible roots. How do you do that? Factors of the last divided by factors of the first. Okay, so this one's easy. Why is this one easy?
It's 1.
Because there's a 1, and there's only one factor of them, right?
Yeah.
Factors of 20, 1 and 20, 2 and 10, 4 and 5, all plus and minus. They're all divided by 1, but since they're divided by 1, life is good. Right?
Yep.
Okay, now we cheated on the calculators. Correct?
I never cheated on the calculator, but I cheated using it.
All right. So instead of using synthetic division, what did we do with all of those numbers?
Plug them
We
in.
plugged them in and we looked for a
0.
0 to make our life easier, right? So we plug in, we start with the first one. So we plug in 1. We plug in 1 to the original. So you're up here, right?
Right.
So you plug in 1 and your answer is going to be 15. Is it a root?
No.
No. Then you're going to plug in 2 and your answer is going to be 8. Then you're going to plug in 4. And you're going to keep going
What's up with
until...
the stuff in the numbers in the middle there?
Well, I was going to make you do it. Do you want to do it?
No.
I already wanted it.
Do we have to do it?
No.
Yeah, probably not. I'm thinking we're good.
That's synthetic. That's synthetic.
That's just synthetic.
We don't need to do it.
You do not need to do that. Okay, but once I hit -2, 2 is a root. Do I have to do synthetic with -2?
Yeah.
Yes. Now, I can do it table style. Most of you did not. Most of you went like this. Agreed?
Yeah, it's just easier.
Yeah, it is easier. I would not argue with that.
Yeah.
Then you had, what are my numbers? 1, -4, -2, 1. Did you do that right?
No.
Okay, how do you do it?
Bring down the 1.
-2.
Add
-6.
6.
12. 10. -20.
Good.
0. Wow.
Okay, so you've done your work right. What did we do with the 1, the -6, and the 10?
X squared minus
1x squared.
Okay, we can write it out. We
X
can.
squared.
That's not wrong. Is it extra work? Yeah. Yeah, because this is just A, B, and C.
It might be working in the long run.
It's A, B, and C, so it's just your quadratic formula. So this is, if you want to, x squared minus 6x plus 10. Everybody good? Quadratic formula is what you did, and then you find your answers. Well, here when I do the quadratic formula, I have a -4 underneath my square root. What does that mean?
Alright.
4i, so they're imaginary. What?
I was gonna say sometimes you can factor that out and keep your wrist.
Yes, you can.
So
And if you can, you do that first.
It's not worthless to do.
No.
She's not extra great.
Well, okay.
See?
Oh, yeah.
Proven.
And
Been a long run.
yesterday, we were sitting around here, show your work, show your work.
It's easier to write.
All right, I'm not going to argue with you. You can. Now, up here, we have 6. -4 is 2i. Everybody okay with that? Square root of 4 is 2.
Yeah.
Square root of negative is I. Okay, how do I reduce this? Yeah, divide who by 2?
Everything.
Everything. So
Everything.
6 divided by 2 and
2.
2 divided by 2. That's how you get 3 plus I and 3 minus I. If I ask you for all of the roots, you have to list all of them. So the -2 is the first one you found using synthetic. The 3 plus I and the 3 minus I are the 2 you found using your quadratic.
Alright, I got a question. When will you ever, like, use this form of finding zeros in like,
Use what?
what we're doing right now? Like, when do you use it as a function in like,
This is when you do, like, the engineers I know in Switzerland. When they are
oh yeah,
in
like that
their,
one guy, yeah.
well, actually, those are the ones I know. I don't know very many
You actually
engineers
know?
here. Yeah. Hugo is his name.
Hugo.
So what he does is he has a wave pool, and his job is to, because over there they have tons of earthquakes and tsunamis and
Yeah.
stuff. So they have to
In
figure out
Switzerland?
how, yeah, because that's what they do. So what they do over there is they have to do their wave pool, and then this tells them where the thing's gonna break apart.
Is that where Kit Kats are made? Hershey.
So just saying,
That's a
there's your answer.
Hershey.
Okay. You didn't think I'd have one, did you?
So what I'm saying is like,
I'm confused.
I'm not a guy that
You
studies.
saying this is?
Yeah, I'm pretty sure you will never do it, Logan. I have no doubt.
I get
What if he's an engineer?
It teaches us to think in new ways.
Yeah.
Well, where are you gonna be in month?
Probably like
That's
There you
It's
go.
the president.
Here we go.
Obama.
You guys are not gonna get done because you're off track again. Okay, x to the 5th, how many answers?
5,
5. How many are you going to have to find synthetically?
34.
4,
Mm-mm.
3,
1,
3.
3.
Because how many can you find using the quadratic?
2.
2. So you have to find 3 synthetically, 2 quadratic. First thing I want you to do is list all of them. Check with your neighbors to make sure you agree. Split them up so you're not doing all of them with your neighbor, and find the 3 that work with your synthetic. Okay, go.
Hey, we have to use my name?
We're doing it right. So when you find one,
But nothing else.
Okay, maybe it doesn't work, but it worked the first time when they first did it.
okay, so everybody found one, right? Okay, so once you do synthetic, you're using these numbers the second time, right? Now Coster said one didn't work again.
It does.
I
Not,
think
Little does he know.
Little does he know.
but I tried it. I'm never wrong.
You're way off.
Looks like it works again.
stand corrected.
Okay,
Wait,
find the third one.
wait, so, is that, because there are 2 plus 1?
I forgot.
Do you remember on your quiz, there was 2 3s, right? This one here happens to turn at 1, so one of its waves touches at 1.
So it'd be -1 too?
That's why I
You
was
could
wrong.
try -1.
Well, I don't get how you have 2 1s up there. Of course they're gonna be the same.
No, no, no,
No.
no.
So use the last
No, no, no.
equation.
I took the one out of the first one, right? So this is the synthetic that I'm using the second time. So since one is already out, he will not work again unless he works twice.
Buddy boy.
Okay?
See, I
That's impossible.
You can write that wrong, or you, wait,
Question, go.
so you use, what you use for the other one? The
It's
bottom?
negative.
Yeah, okay, so I did synthetic, right? So these are my new coefficients.
Yes.
So this was x to the
Might you have an
5th.
extra one? Does-
I have an extra one.
Yeah, right there. By the other, by the box.
Oh.
No,
It's
that's
'cause you
just
have to
carry
plug it
down
in.
one.
Yeah,
Dude.
you carry the one down.
Really.
Is it just from the top?
Yeah.
Yeah, you wrote a group difference, right?
I don't know what I did, Nikosha. Are you understanding?
Mm-hmm.
Okay, so this is x to the fourth, x cubed, x squared, x. No,
Negative
Right.
2, so you put it down.
that's what that represents.
Negative 2, 0, 0.
I took an x out, so now I'm x to the fourth graph. So now I'm working on an x cubed. So now you have to find one more synthetic in here that works. So one worked twice, now you gotta find the other ones.
Can I say it right now because I know it?
1 squared.
Oh, it's right.
One
That's
times
not the
2.
same.
No.
All right, Coster said negative 2 works. Does everybody agree?
Yeah.
So if you plug in negative 2, he's right. Okay, what does this represent, Aaron?
That's right.
X squared plus 4.
I'm so
Okay. Oh, why are you lost?
So you don't use an actual original equation for each one?
No,
See, that's what we're confused on.
no.
We're using the,
You have to take every factor out. If you don't take the factor out, you can't
So-
find the remaining factors.
So minus the last two, the negative 2 and 1. You start at the original 1, okay?
Correct.
So you start at that, and you can literally find 1, negative 1, negative 2,
Boy.
so on, right?
Right?
And once you find that one that works, you use the next equation to have to do the same exact thing with all those numbers again.
They're different numbers, but not in this one.
No, they're the right.
Now, you mean with all of them?
Yeah.
No, not with all of them. If
Why?
you know, let's say you went through and you know 2 doesn't work. 2 will never work. So once it doesn't work, it will never work.
So negative 2 could have been your first one.
Yes,
Negative 2 would have worked for that first one.
yes it will.
No.
See, that's where I'm confused on.
You could put negative 2 in the first one.
for the first one.
It didn't work for me.
Yeah, it would. Negative 2. Oh, I can't. What are my numbers across the top to begin with?
1, 0, 1, 2, negative 12.
Because
Negative 12 what?
It's 5, 0.
Logan, pay attention. Okay, negative 2, first equation.
Okay, negative 2, negative
1.
2,
Negative 2, negative 2.
4, 5, negative 10, 8, negative 16, or 16, 4, 8, negative 8. So then,
Now
once
you
you get
can do
that,
it
you
again?
can do, now you can do a 1.
Now you can do 1.
Or do you even do it again?
You already have
You can try negative 2 again, I guess.
You could try negative 2 again, but it won't work.
So once you got those 3, what do you do with those 3 that we got? 1, 1, negative 2.
All right, now those are 3 of your answers.
Okay?
Now I've got a quadratic. Do I have to do synthetic with a quadratic?
No.
No, because quadratic, we have easy ways to solve those. Why are you confused?
It's just
So do we have to?
Because
put
I
that
thought
bottom
you
in?
just use the same
Yeah,
equation.
that's what I was thinking.
No,
Again,
you always use the reduced equation. Always.
So you can
Otherwise, you'll
literally
never
take-
get
Yeah,
done.
you'll
You
never
could
get
literally
it.
take 20 pages of paper to figure out an answer.
You could.
If you want to, yeah.
If you want to get the right answer, get an A.
Yeah.
Might take
Wait,
you a
you
while.
better bring me a notebook.
Okay, what was yours, Nikosha?
Did you have to have that other negative 2? You just
I'm
started-
gone, dude.
No, that was showing Logan that you could have started with negative 2 if you wanted.
See, this is
That's
like
all it
one
was.
page.
So this is where I'm assuming most of you start, because all of you start with the positives. So you would have found the 1. And then I would assume most of you wouldn't have found the second one. You would assume it only worked once.
I guess I don't
The
know.
reason it's here is to make you remember it can work more than
I
once.
don't even miss it because I didn't.
That second one, why give 2 ones when you got done with the first one?
Okay, I put in 1, and I got this equation.
Yes.
By looking at it, I know 1's going to work again.
But why do you 2 ones? When I get up my equation, I only have 1.
Why do I have 2 1s here?
Yeah.
That's one.
You mean, okay, so you drop the first one.
No, why?
1 times 1 is 1. 0 plus 1 is 1. Do you not have? Do you have the 0? Did you remember your 0 in synthetic?
Can you like?
Mason,
I think you need to
did you do this one
I did all
correctly?
that, it's just
See, use the reduced.
Good for that.
No, you have to see something as problem.
Okay, Mason's better now. Everybody else better? Voices off, eyes up. So we got 1, 1, negative 2. We're down to x squared plus 4. Now we're going to use Aaron's trick because this is simple. X squared plus 4. Do I need to use the quadratic formula? No, because I can set that equal to 0 and solve it, correct? So that's x squared equals negative 4. Square root both sides, and what do I have?
Minus 2i.
Equals plus or minus 2i. So my factors are 1, 1, negative 2, actually my red's not my factors, 2i, and negative 2i. Do I have 5?
Yes.
How many was I supposed to have? 5. I'm done.
Yeah, plus or minus 2.
Yes.
Yeah, you can put x plus minus 2i and that work for.
You can put plus or minus 2i because that counts as twice. Yes. Okay, are we good?
So, I think
This
this
is
is
simple to me, and that's the way you
sure lost from the beginning, because I guess I never took it as you explaining that you have to drop that original, not the original.
So you didn't listen to me 4 days ago.
Well, I said,
How's that working for you?
Yep.
I actually think I was
You always use your reduced equation, otherwise you're not taking out your factor.
Oh.
If you're not taking out your factor,
Yeah, I've never done that.
I've never been using the reduced equation.
then you've probably been having
That is
difficulty.
probably the first time you've said that.
Wait, what?
Dead serious, I've never thought.
They didn't use the
Just going back to the top.
Okay, now that you're all better, let's go on. Okay, now they're going to give you, guys, you're behind. They're going to give you conjugates. Now remember what a conjugate is from yesterday?
Yes.
Yes, so if I give you 3 plus 2i, what's the conjugate?
Minus 2i.
3 minus 2i. Okay, when they give you a root, if they give you an imaginary number, the conjugate is automatically a root. So if they give you 1 imaginary, they've really given you
Two.
Imaginary.
Yes, always. So right now I'm going to give you the roots, and then you have to create the equation. And then we're going to give you part of the roots, and you've got to find the rest of the equation. So there's a lot to do. So I'm going to give you 7 and 3 plus 2i. What have I really given you?
7.
3 plus 2i, 3 minus 2i.
I have really given you 7, 3 plus 2i, and 3 minus 2i. How many roots are there?
3.
3. So this is going to be a what graph?
Cubic.
X cubed. It's going to be a cubic graph. Okay, when you do this, to find that, you have to put them into factors, which is x minus the number, right? So I have to change this to x minus 7. Good? This is x minus 3 plus 2i. It's actually that one, but that's okay. And x minus 3 minus 2i. I have all 3 of my factors are written as factors.
So it's X minus.
Always.
Always. Why?
Kid, how do we solve these?
I have a name.
If I gave you x plus 2, what's the root? What do you do with x plus 2? What do you do with it?
Negative.
Why?
Equals 0.
You said it equals to 0, right? So it's always opposite because you're really subtracting. Okay, here we go. So we got the 3. Now to do this, you have to multiply it. Well, you don't have to, but it's easiest to multiply the imaginary ones first. If you multiply the imaginary and you still have imaginary left, you've done something wrong. The imaginary part will go away because they are conjugates. There's a pattern. Like I can look at this and go straight to this. I will not tell it to you, but when you find it, you may use it. So you can look at that, say that's x squared minus 6x plus 13 with no work.
Why would
I'm
you
not
show
going
that
to
to
show you
us?
how.
I got
I'm
it.
telling you,
I got
it is
it.
possible. Logan, sit down. Now.
I got it.
Now.
No, you just said it.
Okay.
I got it.
No,
Say it.
I don't know. Then only Logan gets to use it.
I'm sure works for that problem. What?
Oh, we gotta be careful. This one's an easy one because there's 1 here. But you gotta be careful. All right. So, first thing you do is the imaginary. So you do your distribution. X squared minus 3x minus 2xi. Everybody good? And you distribute the second one through the negative 3. So negative 3x plus 9 plus 6i. Good? And then the third one. 2ix minus 6i minus 4i squared. Now, you look for what cancels. So I have a negative 2i and a positive 2ix. Good? They go away. 6i minus 6i will cancel. What's I squared? Negative 1. So this negative 4 becomes positive 4. I squared goes away. Change the sign. Are all my i's gone? So I've done my work correctly. Combine your like terms. X squared minus 6x plus 13. Good? All right. Now you have to do the distribution again. And this is the old one. You've done this one for a while. X cubed minus 6x squared plus 13x. Everybody good? Distribute the negative 7 through. Combine like terms.
Unsolvable one on practice.
No, you can do that.
Why do I have an IX left over?
You shouldn't have an ix left over. Okay, do your practice. Check with your neighbor. Let's see what Aaron did. We have x minus 3, x minus 2 minus I, x minus 2 plus I. Okay, when you FOILed that, you should have had x squared minus 4x plus 5. Yes?
No doubt.
Okay, so this together is x squared minus 4x plus 5. Can be done with no work.
Alright, 2 times
Show us
2
how.
is the negative
Nope.
4.
Why?
Because you have to figure it out.
Poor K.
You know that thing between your ears? I want you to use it.
But it's broken.
I came to school to learn. I need someone to teach it to me.
Yeah, if you don't know.
Now, if you cannot inference anything in pain, it's
But
not happening. Okay, now, you have to FOIL this. Did everybody do that? Here, right? X cubed minus 4x squared plus 5x minus 3x squared.
yes, I think I know it.
Did you figure it out? It's not hard.
Isn't it just like,
Don't talk. Everybody happy?
can I write something down and show it to you?
Oh, I know it.
Okay, now, we have to remember all of our factoring. My last class forgot their factoring. Okay, when you look at this is x squared, because now you have to come up with everything. And sometimes they're easy. When I have x squared or x to the fourth minus x squared minus 20, what is that? It's something special. What is it? No, it's not a perfect square. But what can I do with it? What allows me to make it easy?
They're all, you can
They're all
split it all,
even?
can't you?
There's not quite even. There's something else. Because I could have a 6 and a 3 and it would still work.
The reals.
Anybody remember? How many terms are there?
3.
There's 3 terms, so I'm wanting it to be a what?
Just that. I need plus. Well, it's
All right. We want it to be a quadratic. Okay, it's not a quadratic because it's x to the 4th. But I can pretend it's a quadratic if the middle term is half of the first for the exponents. So if I take 2 times 2 and I get 4, it works. So I can use this like a quadratic. If the 4 was a 6, what would the middle term have to be? 3. If this was an 8, the middle term would have to be a 4. Any of that type, right? You can't forget. So now I've got a 4 and a 2, so I can treat it like a quadratic and I can do a simple factor. So we have x squared. What factors of 20 subtract to 1? 5 and 4. It's a simple factor if you recognize it. Okay, now you set them both equal to 0. So 5, and this is a real number, right? So life is good. The square root of a negative 4 is 2i. Everybody okay so far? Now if I tell you to write just the roots, that's done. If I want the factors, you have to do the x minus. So you get x minus the positive 5i, or square root of 5, the negative square root of 5, the 2i, and the negative 2i. Is everybody good? Questions? Yeah, no? All right, you have 2, and they're just reminders of what to do. So you have a 4 term, and you have another 3 term. How do you do the 4 term? What is your strategy? Grouping. And that last one is another what?
What do you just call it?
Yeah, what is that called? A quadratic.
Yep.
So the first one has to be done by grouping. The second one can be done by using your quadratic techniques. Okay, go. Broke it up. So you grouped and grouped. What did you take out of the first group?
X squared.
X squared. X plus 1. What did you take out of the second group?
4.
4. Did your factors match? Yes. So you plug this into?
Yeah, X squared plus 4.
You get what?
X squared plus 4.
X squared plus 4. X plus 1. Because your factors matched, right?
Right.
Now you set them all equal to 0.
Nope.
Yes. So you have x equals negative 1. Square root. So x equals plus or minus 2i. So your factors are 1, negative 1, 2i, and negative 2i. Good. Everybody happy?
Mine from the 13, his way from the 6.
What?
His way from the 6, my way from the 13.
Probably. X minus 2i, x plus 2i. There's your factor. Are we happy?
No.
Yeah.
Okay, how'd you do the last one?
Pretty good. How did I do it?
Yep. What?
Did you do that one?
This one?
Yeah.
Okay, what factors of 2 give you 1? X squared minus 2, x squared plus 1. So x squared equals 2, x squared equals negative 1. So we have x, why did I keep doing that? Equals plus or minus the square root of 2. X equals plus or minus I. So we have x minus the square root of 2, x plus the square root of 2, x minus I, x plus I. No. They all have to. Are we good? No.
But I'll show
Go back where, Mason?
Aaron, did you get yours right?
Yeah.
Did you have x minus
It's so
1i?
simple.
Oh, yeah, absolutely.
What is it?
Mason, what?
See.
Yeah, I'm all up.
Where'd you do that?
Take,
That would work.
I gotta take down here.
Did you hear what Mason did? He said he did the quadratic formula. When you do that, sit. When you do that, you have to remember it's not x equals, then it's x squared. So the two answers you get, you have to square root them. But that will work. Absolutely. Okay, all good? Can I go? All right. Next, I'm going to give you a very long equation and one root. But I'm going to give you an imaginary root. So how many roots do I really give you?
2.
2. So can you take 2 roots out at one time synthetically?
Yeah.
No, you have to use long division. So is this one a long problem?
Yeah.
Yeah. So if I give you 3 minus I, what's the other root I also gave you?
3 plus I.
3 plus I. Voices are off, eyes are up. Oh,
What happened?
I don't know. It's been writing weird today. Okay, now you have to take your 3 plus I and your 3 minus I like we just did and distribute it.
Yeah. Like, we'll have to finish the
Oh, no, I'm finished tomorrow.
Better get a work done.